gentlemen, welcome back for another round. This is Mr. Doolin. I thank you so much for tuning in. What we're going to do today is we're going to take a look at gas stoichiometry. And so this is the stoichiometry that's involved with gases. We've done some of it up to this point, and the major assumption that we've made up to this point is that we can always use this relationship that 1 mole of gas is equal to 22.4 liters of gas. But now that we've ventured into gas laws and just the behavior of gases, we understand that this is no longer true in every single situation. And so what we have to do is we have to adjust this relationship, and we say that 1 mole is equal to 22.4 liters of gas as long as we are at standard temperature and pressure. And remember, STP is equal to 1 atm and 273 Kelvin as a temperature. All right? And so if I'm at anything else but 1 atm and 273, this particular relationship does not work. So how does that affect us? Well, if you see, that gives us 2 different spots on our gas stoichiometry, on our stoichiometry tree that we really have to pay attention to. Are we at STP? And we have to make that distinction from here on out, right? Now, most of you at this point, if we're going to do some converting, right, and we're going to convert liters A to moles A, for example. We started out with 5 liters of gas. I want to convert it to moles of gas. Well, normally what most of you are going to say is, hey, Mr. Doolin, I know that. Divide by 22.4 liters per mole, and I'm good to go. Well, again, that's true, but only if we are at STP, right? The other example that we might see is, hey, what if I'm converting and I'm going from moles B to liters B? So again, I'm over here. I would say, hey, I'm going to multiply by 22.4. Or the other situation, if I'm going moles A to liters A, these are both ending with the gas, right? Notice this one is beginning. The first example, I'm beginning with the gas and converting from it. The last two, I'm ending with the gas, right? And so I'd multiply by 22.4 liters per mole on both of those. Well, again, I need to make the distinction. I need to completely understand that these conversions now will only work if I am at STP conditions. So the real question becomes, what do I do when I am not at STP conditions? Okay, and so the very first situation we will look at is, say, I'm at non-STP conditions, and I'm going to start with liters of a gas. So I'm starting at liters A, right? And I'm at non-STP conditions, so I'm at some other pressure than 1 atm, some other temperature other than 273 Kelvin. So what do? Well, in all of your stoichiometry, if you're looking at the stoichiometry map, to convert to anything else, I have to go from liters A to moles A. So now how do we do that? Well, in Comes and Saves the Day, we're going to use the ideal gas law, or PIVNERT as I like to refer to it, to solve for moles A. So we'll use that to solve for moles A. Now, what happens here is if you just use algebra and rearrange this equation, I can actually rearrange it as PV divided by RT equals N, and the N value is what's going to give me moles A. Moles A. There we go. All right, and so not anything crazy. Again, it's just a recognition. Hey, when do I need to use PIVNERT before I use stoichiometry? Because then, once I get to moles, this can just go regular stoichiometry at that point. And so again, the idea here, if I'm starting with the gas at non-STP, my very first conversion to moles, I have to use PIVNERT. All right, now, my next one. What if I'm at non-STP conditions and I am going to end with the gas, right? So I want to solve for liters B is essentially what I want to do. I want to end with the volume of a gas, right? And so what do? In normal stoichiometry, you'll see this is going from moles B to liters B. I'm going to leave out moles A to liters A because it's the same conversion here, all right? And so what do we do now? Well, at this point, I understand I can use stoichiometry to solve for moles B, but I can't make this conversion because I can't just multiply by 22.4 liters because it's not a true statement if I'm not at STP. And so what we can do, again, a PIVNERT comes in to save the day, right? I've got all my variables, and what I want is volume. And so notice if I just rearrange this equation, I end up with volume is equal to nRT divided by P. And I can actually solve for this liters B value given my pressure and my temperature conditions at non-STP conditions, all right? And you see, remember the R value, that's my gas law constant. I'm going to know it. I would solve for this if you wanted to label these. This would be your moles B, and then the temperature would be your given temperature, and the pressure would be your given pressure, all right? And so nothing crazy, ladies and gentlemen. To simplify this, if you want to write it at the bottom of your page really, really big, start with gas at non-STP, start with Pivnert. End with the gas at non-STP, end with Pivnert. All right? That's the simplest way to break down gas stoichiometry into just a singular sentence. All right? And we'll see lots of examples with these in class. So if you have some questions, I think doing some examples will actually probably answer most of those. But if you do have other questions, make sure you get them down. I'll see you in tutorials for those. Otherwise, I will see you in class.